How's it going, YouTube? It's Adam Ether here. I got Ward Bond here.
Hi, everybody.
You've probably seen us in the last video vaping off these boxes. Ward here is the fantastic creator of these things. He's made these that you've seen in our videos. So Ward, it's good to have you here. Today we're going to go over some battery safety, mod safety, just some general good information that I think everybody should know, just to make sure that we're all being as safe as we can be out there.
The first thing you should know about battery safety is you should know the implements of your batteries. And to make sure that you're operating in the safe limit for your battery, you should know the data on the battery from the manufacturer or from an independent source. The independent source really being the best one for that. In order to know that you are actually vaping within the safe amp limit of your battery, you'll have to know the actual ohms resistance of your builds. So it's imperative to have an ohm meter. We currently stock Samsung 25Rs, EFES 25 amps, and sometimes we carry the Sony VCT3s or VCT4s. Know that the amp limit on those batteries is, at the highest range, continuous limit is 30 amps. So if you're not exceeding 30 amps, you're vaping somewhat safely. The lower the amperage, the safer. So to know that you're actually vaping safely, once you have your coils built, you would actually want to read the resistance on that and calculate your amperage. To calculate your amperage, you use Ohm's law. As
an example, I'd like to kind of run through a little sample scenario.
Okay.
So I know here at this particular shop, we've sold the purple EFES that you were talking about earlier for quite some time. So we have a lot of customers that are using those. So let's use one of those as an example. So in order to ensure that you're being as safe as possible, the best bet is always to use that continuous rating. Would you say?
Yeah. To be on the safest side, to be the safest with the battery, you always want to calculate based off of the continuous rating of the battery.
And for all of you, advanced cloud chasing crazy people out there, I know that there's a difference between the pulse and the continuous and whatnot.
Yeah, there's even burst rating out there on the very high end. So what you really should be concerned with, and what we're going to be talking about today, is really based off of the continuous amp rating. But knowing that a battery, for instance, the EFES, a 35 amp pulse rating, is rated higher for that, is just erring on the side of caution. And when it comes to batteries, it's always best to err on the side of caution and be safe. For heaven's sake, please be safe with batteries. You don't want to be a statistic.
A good reason for that is because the pulse and burst ratings are only for a limited time. And say your device malfunctions and just starts firing in a bag or something, if you're set up for that pulse or burst rating,
you've exceeded that limit.
And then when you got problems, you're going to have a bad time.
Very bad time. Being able to be safe and be in that continuous amp limit, as Adam said, is the most important thing. The reason for that, if you have an accident, you're still in the continuous limit. The battery's been rated for that continuous limit. The worst that could happen is that your insulators on your rebuildable could melt and could actually cause a short. But we'll get into shorts here in just a minute.
Yeah. So with that purple EFES, it's a 20 amp constant. And so I think everybody understands, or continuous, so everybody understands how to kind of calculate this. Let's use that as an example. I have a build on my RDA of 0.48 ohms. So how would I figure out what the amperage is that I'm using?
Okay, so to figure out amps, if you look here, you'll see that amps, or inductance, is related to volts and resistance. So actually, to figure out your amp limit, you divide resistance by volts. So in this case, what is your build?
My build is a 0.48 ohm.
So 0.48 divided by your resistance 0.48 divided by 4.2. Actually, you're vaping on 8.4 because that's a series box mod. In a perfect world, that's 17.5 amps. So he's well within the safe amp limit of his Samsung 25R batteries that he's vaping. So you're perfectly safe there. So you're good.
Okay.
Safer batteries.
So now to go back to your ohm meter, Now you as somebody who's been building coils for quite some time, and you can pretty much, I'm sure, just figure out in your head so many wraps around a certain diameter, you're going to be right at about a certain. So why is it important for you to have your tester?
And that's a very good point, Adam. You make a very good point there. The reason why you always want to use an ohm meter, regardless of whether or not you know the number of wraps for the coil that you want to build and for what resistance it might be, is that those wraps and that calculation in your head doesn't tell you whether or not you have accidentally shorted the coil at some point or some place inside of the actual buildable atomizer. So this will tell you instantly when screwing this on here and screwing an atomizer on here and actually turning it on, you'll see if it's shorted or not. So in this case, I'm actually going to take a second and I'll screw my atomizer on here, flip the switch, and what I'm going to do is try to create a situation where I have a short. Nothing.
Okay. So how does that impact your battery? I mean, what's going on at that moment? If you didn't test that, you didn't determine that there was a short, and you put that on and you hit that button, how does that work in the calculation?
What actually happens is positive and negative are meeting at the same time, and when that happens, the battery starts draining every ounce of energy it has at once. So since there's nothing to resist that current, that like there normally is when you have a little atomizer on your rod, you'll actually end up creating heat, lots of heat. And then what can happen and will happen as if it continues is the batteries will heat up to the point where the casing starts to melt off, and then the batteries, in worst case scenario, will actually start venting. When I say venting, that's actually venting gases, which are flammable gases, that will typically come out of the positive or negative end of the battery if it's a good battery. Cheap batteries, which we would never recommend you vaping on mechanical or rebuildable atomizer, or on a device where you're going to be using a rebuildable atomizer, could actually vent from the middle or burst. So, which is a very scary scenario.
And we'll show you some pictures right here of what that would actually result in.
And actually, you can do a lot of damage to yourself and your property. And you want to be safe. A great example of reason to be safe is you want to avoid fires, obviously. Right. You want to avoid hurting yourself. You could damage your hands. You can damage your
especially knowing that these batteries are readily available in so many different stores, and I believe initially weren't they really created for like flashlights?
Absolutely.
And so the amperage that you're pulling for an LED battery is so low that a lot of these batteries that are the exact same size, these 18650 batteries, 26650 batteries, can be as low as I've seen as low as 4 amps. So just know that whenever you go get these batteries, they're not all designed for the purposes that you're using them for, and the amperage limitations on those batteries could be so low that you would, no matter what you do, you're going to be outside those means.
Those safe limits, absolutely. So what you'll want to keep in mind is that very few batteries are actually created for vaping. And even if a manufacturer states that their cells are actually created for vaping, they actually may be rewrapping cells from other manufacturers to create their product.
Oh, and down below the video, down there,
down there.
You'll find some links as well to some of this information as far as amp ratings for different types of batteries, and some information about how to calculate Ohm's law, and other information that we're looking at. So go down there and take a look at those links. So we were talking about them shorting out and the different types of connectors and whatnot. And can you show us how that can happen and what we're talking about?
So one of the things you'll obviously encounter when you're looking at mods or shopping for mods is different types of switches and connections on mods. This one in particular actually has a connection that we refer to as a hybrid connection. So the way that actually works is the atomizer sits on top, but it actually has a hole in the top of the mod, right here. Instead of having a 510 pin connection like this does. So this is a Manhattan, and inside here you actually have a 510 pin that makes contact with the bottom of the atomizer, and then in turn makes contact with the inside of the battery.
So one of them, it's making a direct contact.
One's making a direct contact with the battery, the other one is actually, there's a mechanism. Inside here, you actually have a pin that makes contact with the top of the battery inside the tube, and then the top of that pin makes contact with the atomizer. Now, I'm sure lots of you already know this, but there's plenty of people out there that are just learning and can, benefit from this kind of information.
So how does that impact battery safety?
How that impacts battery safety is that hybrids are really, in my mind, more for advanced users, not necessarily for beginners, because of the safety issues that can result from owning or using a hybrid mod. And the reason for that is because this pin at the end of this 510 has to make direct contact with the top of that battery. If this pin is screwed in too far and the negative side of this 510 connection makes contact with the top of that battery, then it's going to create a dead short, and then you're going to have that same scenario that we were talking about, how the batteries are going to heat up and or vent, or in worst case scenario cause a fire. So when working with these kind of mods, the first thing you'll always do is remove the battery, unscrew the bottom of the mod. Inside here you'll check to make sure that the 510 connection is actually extending past the top cap and will be able to make contact directly with the battery once it's inserted. Then you'll put in this case, there's just no locking mechanism. This is just a little switch that screws into the base. This is a simple mod, very simple, like the name states. I love this little mod. And with the Derringer, it's quite a nice build. Quite a nice little setup there. And it makes direct contact with that positive pin. And the reason why these are somewhat desirable, or in my opinion, very desirable, is because they actually have lower internal resistance than other types of mods, since they make that direct contact with 510s, with the 510 positive pin. And you use a little bit less battery juice when you're more efficient like that as well.
So they're really nice to have.
They are.
They do produce a really nice hit, very low voltage drop. For the advanced vapor, they're absolutely wonderful.
Make very good choices. Do yourself a favor, do the world a favor, do vapors everywhere a favor, and make good choices when you're deciding what you're going to vape on what. So if you choose to vape a tank on a variable voltage device, you're making a safe choice. If you're using it on a mechanical, just be sure that you're vaping on a kind of mechanical that it's safe to vape those kind of tanks on. And if you have any questions about that, come here. We'll be happy to educate you and show you what is safe to vape on what and why. A good example of why you would want to avoid using a sub-tank on a hybrid is because this 510 connection is actually spring-loaded. So if you screw this in too tight, it would make direct contact with the negative side or the outside of this 510 connection.
From the
pressure itself of actually being screwed in, the outside of this will make contact with the top of the battery and short. You need to regularly, which if you're using a hybrid, you have to be a little bit more cautious and regularly check your 510 connection. When you change your batteries, always check your 510 connection again. Just erring on the side of caution here, looking to make sure that center pin on the 510 is extending past the top of that mod and making contact with that top of that battery, so it's not making contact with the negative side of that 510 connection.
So make good judgment calls, and you guys know, I mean, you use your devices every day. I know that I have this thing. I might as well have it surgically attached to my hand.
Ditto.
Yeah, right?
Yeah.
I love this thing, but if I felt that the box seemed to be getting a little too warm, or if my mod that I use on a regular basis it seems like it's getting warmer than
those
usual.
Are all warning signs that something's going wrong.
Yeah, trust your instincts. Something may not be, exactly right. You might want to check it out. And it may not be a serious situation. It might just be,
that you've been vaping too much.
Vaping a little bit too much.
That's my problem more than anything. And what can happen is if you're noticing heat on the outside of your mod, it could just be heat from your atomizer,
Keyword, could.
Could be.
Could be. So
Could
so
be.
trust your instincts and check that kind of stuff out.
Yeah. But again, erring on the side of caution, you want to make sure that you're doing the right thing and vaping responsibly so that you're safe for you and everybody else that cares about you.